Chapter 7, Section 1 is called Radical Functions. Radicals, and radical functions. So, they start out with a basic radical, and they say, find, or that. That is a radical. Some people call it a square root, and that's the same thing. Square root 25 or radical 25. We know that it means, right? Just so that you know, negative 5 times negative 5 is also 25. But when you see a radical, it wants you to use the positive root. So, what's the square root of 0? Well, 0. What if you see a fraction? Do you take the square root of the top or the square root of the bottom? Yes. I bet you were thinking both, and that's right. You take the square root of the top, anything in there. So the square root of the top is 3. What if you see a variable, like, for example, x to the 10th? Well, what times itself is x to the 10th? Well, you might know it, or the 5th is x to the 10th, because remember that you add exponents when you multiply the base. You don't multiply them. So, all you have to do to take the square root is just take half of this, whatever it is. So I have x to the 5th. What if I gave you the square root of 36x to the 6th? Well, we take the square root of the coefficient and then the square root of x to the 6th. And the square root of x to the 6th is x to the 3rd. And an easy one that when I have in-class quizzes, I often give them something like this. Because a lot of kids will accidentally write x to the 4th. But x to the 4th times x to the 4th is x to the 8th. So we want what times what is x to the 16th. So we want half of x to the 16th. Because then we know x to the 8th times x to the 8th is x to the 16th, isn't it? When you multiply bases, add exponents. Alright, now one more thing they do is they say, what if you have the square root of negative 25? Well, for now, we don't know a number times itself that's negative. If it's negative 5 times negative 5, you get positive 25. If it's positive 5 times positive 5, you get positive 25. Solution to it, but we'll learn it later. Now don't get confused with that and this. Those are not the same, right? Because in this case, we take the square root first and then times by the negative. So the square root of 25 is 5, and then timesing by the negative, my answer would be negative 5. Now, another thing they can do, they can stretch you and go to cube roots. So now we're thinking, what times what times what? 3 times is negative 8. And since there's 3 of them, they can be negative. Because look, 2, negative 2, times negative 2, times negative 2. 4, and 4 times negative 2 is negative 8, isn't it? So you can have odd roots, cube roots, fifth roots. You can have odd roots of negatives, but you can't have even roots of negatives. Square roots, fourth roots, you can't do that. So ours for this answer is negative 2. What if I gave you the cube root of 1/64? Well, what times what times what? 3 times is 1. Well, you know 1 times 1 times 1. What times what times what is 64? And you might know that it is 4. And you can use your calculator. Make sure you know how to use your cube root buttons. Let's do one with a coefficient and a variable. Let's do the cube root of negative 64, x to the 6th. Alright, now the cube root of negative 64 is the same as the cube root of 64, but it's negative. So it's negative 4, right? Negative, and you can check that. Negative 4 times negative 4 times negative 4, and you get 16 times negative 4. Oh, yep, that is negative 64. Now, what's the cube root of x to the 6th? So I need to think of something that I'm going to multiply 3 times, and it has 2 plus 2 plus 2 is 6. And here is your shortcut. To get that 2, this is what you can do every single time. You can do 6 divided by the second. And look, that works here too. 10 divided by, what was the root? 2 is x to the 5th, isn't it? So that will always work. This one, 16 divided by 2, x to the 8th. 6 divided by 2, x to the 3rd. In our case, 6 divided by 3, x squared. Alright, let's do a little bit higher ones. What if I ask you the 4th root of 16? Well, you can punch in your calculator, but they're pretty nice. They're pretty simple. So you might just start trying numbers, and you would see that 2 times 2 times 2 times 2 is 16. And you can check that. Just multiply it out, and you'll get it. How about the 5th root of negative 32? Now, excuse me. So I can have a negative, and what times itself 5 times is 32? Well, 4 of them was 16. If I did one more, that would be 32. But they all need to be negative, don't they, to make a negative 32. What if I want the 4th root of negative 16? Well, we just did the 4th root of positive 16. But what times itself 4 times is negative? No real number. And that's what they say. We can't do it yet. There's no real number. Now, this is a good example, because what if you have a root and an exponent that are the same? And just so you know, that 5 can be written out here, inside, or right in the middle power. And guess what? If those are the same, they just cancel. If you multiplied this out 5 times and then you took the 5th root, it would just equal what's in that parentheses. Now, I don't want you to be thrown by this, but in part of your homework it will say, assume x is any real number. That means it can be positive or negative. So if you see something like this, well, we know that we just go 6 divided by the root, which is 2, and we get x to the 3rd. But we have to tell them that we picked the positive root. Just like right here, we picked positive 5, not negative 5 for the square root of 25. So we have to tell them that our so when you see that in your instructions, your x's will, don't let that throw you. It's not going to be a test question that. I just want you to understand why you're seeing absolute values. They're just telling you x can be anything. So you have to tell them you pick the positive one, because we know that this radical means the positive root. We always pick positive. So in this one, again, if this were in the instructions, I would have to tell them that x plus 6, I'm picking the positive x. The 4th and the 4th root would cancel, but I would see my answer in absolute values. Now, the last thing we want to talk about are those radical functions. So when we're dealing with radical functions, they just use function notation. And so you could see something like this, where they say that f of x is x plus 2, and g of x is the cube root of x minus 1. And then, for example, they could say find f of 7. So we just go to function f, and we plug in a 7 wherever we see x, right? So then simplifying, we get f of 7 is 3. What if they said find g of 9? Well, then I go to my function g, and wherever I see x, I plug in a 9. So I get the cube root of 8, and we know that 2 times 2 times 2 is 8. So g of 9 is 2. Alright, now the last thing they make us do is graph radicals. So if I wanted to graph g of x equals the square root of x minus 1. Well, let's go ahead and do an xy table, and then we'll draw our points on a corresponding Cartesian plane. So let's put in 0 for x. If I put in 0 for x, I get the square root of -1. And we saw up here, oops, that was odd, that was okay, right here. We saw that we can't have the square root of negatives because the answer is no real number. That there's no graph at 0. There's no corresponding point to graph at 0. But when I put in 1, what happens? 1 subtract 1 is the square root of 0. And the square root of 0 is 0, isn't it? So I can graph that over 1 up 0. Let's put in 2. If I put in 2, I get 2. 1 is 1, isn't it? So now let's pick a perfect root. So I'm going to go all the way to 5. Because look, if I plug in 5, 5 subtract 1 is 4. And the square root of 4 is 5 up 2. Now, you could keep going. You could plug in 10 and get 3 and so on and so forth. But I'm going to show you that the graph of a radical, this is the shape that you're looking at. And it's always this round curve that goes just like that. And it goes forever that way. So if you had to tell me the domain and the range, do you remember that? Axis, what x values coordinate graph. And you can see that they start at 1 and they include 1. So we're going to use a bracket. And they go forever. So they go to infinity. Now the range, again, I'm talking about the y values, but again, they start right there at 0. Oh, not again, this one started at 1. Now they start at 0, don't they? And they include 0. And this goes up slow, but it's going to go up and up and up and up. So eventually, we'll get to infinity. So they do give you some domain and range problems too. So, I do think that, believe it or not, I have seen on final exam a graph with a radical and they ask you to find the domain and range. So if you see that type of problem, ask for another one, do look at the examples, make sure you're good at that and you understand that question. Alright, you guys, good luck starting chapter 7.